Here is an excellent video for all those who want to learn trigonometry right from the basics. We'll begin with the right triangle, understand the three primary trigonometric ratios, evaluate their values, and take up examples relating trigonometric ratios, which will include cofunction and quotient identity. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the viewers and subscribers for watching my videos and sharing excellent suggestions. Some of our subscribers want a new series on trigonometry, starting from the very basics. Here is it for you. So we'll begin with primary trigonometric ratios. And in this video, we'll first discuss what is a right triangle. I know all of you know it. Anyway, we'll just define it in our own terms the way we are going to use it in trigonometry. Then I'll share with you the three primary trigonometric ratios, sine, cosine, and tangent. We'll see how do we evaluate these trigonometric ratios given right triangles. Now moving forward, there are some very important relations, but early on, it is good to explore these relations, and therefore, I have taken examples to prove cofunction identity, to prove quotient identity, and another important thing in trigonometry is to rationalize denominators whenever you have radicals. Now, many students early on do not understand the significance of rationalization, or they are not aware of this process, and therefore I'll take a small example to do it. And then there will be 10 practice examples for you. Well, I will actually share with you 10 examples, means I'll solve them for you, explain everything, and then there will be 10 practice questions for you to do at the end. Right? So I hope you're getting it. What I mean to say is that the examples which I'm going to share with you are these. Right? So these are actually 10, but I added one more, made it 11, kind of bonus. And then after this, we are going to have practice questions for you. So practice questions are like this. Similar to what we had been doing, right? You get the idea. These questions are very similar to the examples which we are going to explore. So I think that should give you very good practice on this particular topic. Now, before this topic, what you need to cover is similar triangles and congruent triangles, right? So what you should know is something like this. You should know similar triangles and basic ratio concepts. Is it clear to you? If not, I'll provide you with links so that you could just practice. Perfect. So let's begin with this particular lesson. It is important that we are only evaluating the value of trigonometric ratios. We will not be finding the angles in this particular set of videos, set of questions, but in the next one, we'll work with the angle part of this. That means inverse of trigonometric ratios. Clear? Okay, so let's begin with the basic concepts. So as I was saying, first let's look into what a right triangle is. Okay, it sounds funny, right? At this stage, I'm telling you what is a right triangle. So our right triangle is shown here, which is like A, B, and C, right? We have a right angle at B. So I'll write this as that angle ABC is equal to 90 degrees, right? So normally you put C here, right? Hypotenuse is C, but I purposely kind of changed it, right? Perfect. Now, how do you name angles? Angle A is highlighted here, which I could say angle A. But normally, I could also write this as angle CAB, right? Angle CAB. Perfect. So that is how we are going to write the angles. Now, angle C, which normally if I write like this, if there is no confusion, it is okay, right? So that is angle C, which is also written as angle ACB. So the idea is to write that vertex in the middle. You could name these angles. For example, I could write theta for angle A. So in that case, my angle A will be theta. And I could write another Greek alphabet, phi there. So in that case, angle C will be phi. So for some students, these theta and phi might be new terms. But in trigonometry, as soon as you begin with, Greek symbols are very, very important since they really contributed to this topic, right? So see what these symbols are. These are their alphabets, right? This is like alpha, right? This is alpha. This is beta. And this is gamma. And theta and phi I have introduced you. There are many, right? You can go through this list, right? If I introduce new ones, I'll tell you how to pronounce them and what are these, right? But basically, if you see something like this, just treat it as a variable, right? Which we are mentioning theta and phi. Now, in a right triangle, theta and phi are related, correct? Because, the sum of theta and phi is 90. And therefore, I can also say that phi is equal to 90 minus theta. So normally we are working in degrees. But I forget to write degrees, right? But as a student, you should not forget to write degrees. It's kind of important to write degrees. You might lose marks, right? Okay. So phi is 90 minus theta. That's very important to see. So this is the right angle triangle whose vertices are A, B, C. So the triangle which I am going to describe with you is triangle ABC. So when I write triangle ABC, normally B 90 degrees will be written in center. But explicitly, we have to mention like this. You get the idea. Now the sides of the triangle. Let's talk about the sides of the triangle. Side opposite to A, CB. So CB is opposite to A. Angle A. Do you see that? Now, so I may refer this when we talk about trigonometric ratio as opposite O, capital O, right? And A to B is adjacent to angle A. When I say adjacent, it really means that it is between the vertex A and 90 degrees. You see that for that particular angle. So side adjacent to, when you look at phi, will be the one which I am saying opposite side. You get the idea, right? So kind of, do you understand this part, right? So when we use a right angle triangle, we refer to sides as opposite and adjacent. And of course, the longest side, which is opposite to right angle, will be referred to as hypotenuse. Now, what I do sometimes is that I use the word capital H for hypotenuse, capital O for opposite side, and A, capital A for adjacent side, just for a short form, right? We may write OPP and ADG, but this is what I do, right? So I hope you have understood my right triangle, which is exactly same, but we are referring to the sides as opposite and adjacent, and we are referring these angles related with the relation 90 minus theta. So it's a very important relation. We'll see its significance soon in this particular video also. Perfect. So I hope till now everything is absolutely clear. Now these are very fine points which you should know early on, since many times students are asking for these questions later on, like what do you understand by the opposite side? What is angle phi? Correct. So in our case, uh, it is the angle which makes 90 degrees sum with the other smaller angle, the acute angle, right? So these are both acute angles, correct? So in a right angle triangle, theta and phi are both acute angles. Okay, perfect. So let's move on with the trigonometry part. Very interesting. You were waiting for it for so long. There are 6 trigonometric ratios. However, there are 3 primary trigonometric ratios. These are called sine, cosine, and tangent, which are defined here. So with respect to our angle A, which is shown here, highlighted in yellow, we say sine of A is opposite over hypotenuse, cos of A is adjacent over hypotenuse, tangent of A is opposite over adjacent. So as you can see from A, the side CB is the opposite side and AB is the adjacent side, AC being the hypotenuse, correct? So, strictly speaking, when you write these terms, it is like sine, right? Everything in lowercase, cosine and tangent. Now, always these words sine, cosine, and tangent are qualified by sine of what? Sine of an angle, right? So, in short form, we give that angle sine A, cos A, tangent A, right? But we do not write the full form ever, right? Never you'll see that. We'll always write them in short form, and that is sin. Some students call it sin, which is absolutely wrong, right? Lowercase, right? Cos A and tan A, correct? All are lowercase. Does make sense? So these are the three primary trigonometric ratios. Okay, sine A, cosine. How are they defined? Sine A is basically equal to, it is the ratio of two sides in a right triangle. All these trigonometric ratios are ratio of two sides in a right triangle. Okay, so basically you can say ratio of two sides in right triangle. Is that clear to you? Now, since it is a ratio, they do not have any units, okay? So it's just a number. So sine is defined as written here, opposite over hypotenuse. You see that? So I will write this as capital O for opposite, or let me write for now opposite over hypotenuse. Does make sense? Cosine A is adjacent over hypotenuse and tan A is opposite over adjacent. You see that? So a triangle which have 3 sides and 3 angles, 6 quantities, all this can be combined in trigonometry. So trigonometry actually gives you measurement of all the things and linking them together. So in this particular triangle, you can see that the opposite side is CB. Do you see that? So CB over the hypotenuse, which is AC, that is sine of angle A. As far as cosine is concerned, we are looking into the side AB over the hypotenuse, which is AC, and tangent ratio is CB, the opposite side to A over AB. Is that clear to you? So these are the ratios, which I have described here in the table beautifully, correct? Now, most students in North America remember this with SOHCAHTOA. SOHCAHTOA means sine. This is the sine ratio. Opposite over hypotenuse. Then we have the cosine ratio. Adjacent over hypotenuse. And then we have the tangent ratio. Opposite over adjacent. I have organized in my own way, since they are ratios. Sine S is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Makes sense, right? So that is how we will remember these ratios. Perfect. So as a question, what you could do is you can find or you can write what is sine of C, right? Cos of C and tan of C, right? So if you see from the other vertex C, then the side opposite will be this one. You see that? AB, right? And hypotenuse remains same, but adjacent and opposite side will interchange. And therefore, the sine and cosine values will interchange. You get the idea, right? So try to write down to really appreciate what I'm trying to say. Okay. Now, we talked about trigonometric ratios, but let me just add in here something about trigonometry. Trigonometry comes from Greek terms trigono, which means triangle, and metrikos, which means measure. Perfect. So you have seen how we measure the angles and the sides in trigonometry. That's what it is. In true sense, trigonometry begins with measurement of both sides and angles in any triangle and extends to help us even explore the celestial bodies in our universe. So all the mountains have been, their height has been figured out with the trigonometric ratios. Even celestial bodies, the movement of all the planets have been understood by trigonometry. So finding distance from Earth to Sun is a problem of trigonometry which was solved many years ago. You can see its strength, right? Now I stay here in Toronto, Canada, and this is our CN Tower, right? You can find the height of this CN Tower while walking downtown with these measurements given to you using trigonometry. So that's the whole thing, right? It's a very powerful topic. Perfect. So coming back to what we just learned, and I summarize this as things to remember. So again, we are using a triangle ABC with opposite, adjacent, and hypotenuse. Things to remember, sine A, cos A, and tan A are called primary trigonometric ratios. Trigonometric ratios have no units since they are just ratios. All the trigonometric ratios are written in lowercase, not capital T for tan, okay? Greek symbols alpha, beta, gamma, theta, delta are commonly used for angles. Mnemonic to remember the primary ratios. SOH for sine, correct? So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tan opposite over adjacent, which I prefer to write in this fashion since these are ratios. So till now, no problems, correct? So are you ready for examples now? Perfect. So let's begin with some examples, right? Fast forward. So example 1, identify primary trigonometric ratios for angle A. Very clear. This time we are given the sides. So can you help me write down? Primary trigonometric ratios are what? Sine A, right? Lowercase. It is opposite over hypotenuse, as I was saying, right? I prefer to write like that, which is 5 over 13. Makes sense, right? Correct. So what is cos of A? So cos of A is adjacent over hypotenuse. So I'm writing A over hypotenuse so that you kind of remember them, right? So it is 12 over 13. So whenever we talk about sine and cosine, hypotenuse is included, right, in the denominator part. Do you see that? And now let's write down what is tan ratio. So tan A is what? Tan A is opposite over adjacent. This O is not 0, right? And this A is not angle A, adjacent, right? It is like adjacent and opposite. You get the idea, right? 5 over 12. Perfect. Now in trigonometric problems, right angle especially, we'll not give you all the three sides. We'll only give you two of them, and you can apply the Pythagorean theorem to find the third side. You get the idea. So in this triangle, actually, one side was not given, so you could find it. Perfect. But taking it as a first example, I kept it very simple for you. Perfect. Now, you can actually figure out, write down what will be for angle B, right? Instead of A, you can write for angle B. Make sense? Perfect. Example 2. Identify primary trigonometric ratios for angle theta. See, now we are getting into normal word theta so that you get used to theta, right? Now look here, it is in a very different position and you have to see from theta. That becomes the opposite side, correct? And we don't know what is the length of this side. This is what I was telling you, correct? So first thing is you need to find this length, right? So GHI. So the triangle given to us is GHI. Okay. So HI, the side, is a smaller side, and therefore that should be square root of 13 square minus 5. Correct. Right. So which you know is 144, which is 12. Right. Use your calculator, but you think this is actually without calculator exercise. Okay. So this side we just figured out is 12. Not a big deal, but remember that you have to apply Pythagorean theorem sometimes, in fact always, to get the third side in a right triangle because it's not normally given to you, right? Okay, so we can now write what is sine theta. So sine theta is equal to, so I'm not writing opposite over hypotenuse, I'm directly writing 12 over 13. You get the idea? Now you know, right? So sine is basically opposite over hypotenuse, cosine is basically adjacent over hypotenuse, and tangent is opposite over adjacent. Makes sense, right? So that is sine, and what is cos theta? Cos theta will be equal to adjacent. Now side adjacent is 5. Do you understand? Adjacent means what is very close to the angle and 90 degrees, both of them, right? Adjacent side. Makes sense? Over 13. So hypotenuse is involved in both sine and cosine, but not in tan, okay? So tan theta is the ratio of opposite side, which is 12, over adjacent, which is 5. Makes sense? Correct? Perfect. And I'm writing this again and again for you to register. So remember what these ratios are. Example 3. So sometimes we have a statement, not the triangle. So the statement will be, identify primary trigonometric ratios for angle P given triangle PQR, where PQ is 8 centimeters, QR is 6 centimeters, angle PQR is 90 degrees. Perfect. So basically, this diagram which I am showing you will not be given to you. So you'll have to sketch the diagram. Remember that part whenever the statement is given. So sketch a diagram just as I have done here. After reading the problem, assume like this, okay? So PQR is 90 degrees, right? So this portion is right there. You see that? Okay. And we have labeled the sides PQ as 8 and QR 6 centimeters. We need to find the angles with reference to angle P. Perfect. So you can write down what is sine P equals to, what is cos P equals to, and what is tan P equals to, right? Now, before that, we have to find the hypotenuse. It is not given to us, right? So it will be basically 8 square plus 6 square, the longest side, square root, right? So that is 6436 makes it 100, square root is 10. So that is how you have to calculate. It is all without calculator, okay? And remember the ratios. We are writing like sine, SOHCAHTOA, 2, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. Makes sense, right? So I hope you got the answer for these. So for from angle P, the opposite side is 6 centimeter and then hypotenuse 10 centimeters. Centimeters cancel. So we get 6 over 10. Now you should actually write them in the lowest terms. Simplify them. Dividing by 2, we get 3 over 5. So 3 over 5 is the correct answer. Cos P will be 8 over 10, which could be simplified and written as 4 over 5, and tan P will be 6 over 8, which will be dividing by 2, we get 3 over 4. Makes sense? Clear, right? So note, you have to simplify to the lowest terms, right? We have mentioned it in the question also. Perfect. But normally, it will not be mentioned, but you have to do it. Perfect. So let's move on and take the next example, which is cofunction identity. So we'll talk about it. Well, remember one thing, that you can always contact me to learn directly. Most of my students are right there on the top. Their foundation is pretty good. And some of them are getting awards and scholarships, just like Akshit.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshit Kandivani.
Great. Our student, Akshit, gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel.
Okay, now let's look into example 4, where we're talking about cofunction identity. What is this? Okay, let's explore. So the question here is part A. In triangle OPK, verify that sine theta equals to cos k. Explain if cos theta equals to sine k. Okay. So let's first do this part, right? So, okay, verify sine theta equals to cos k. So let's find out what is sine theta equals to. Triangle is given to us, right? This is the triangle given to us. So if I take sine theta, let me rewrite for you. Sine is opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite over adjacent, opposite side being 2 for us. Very good. And hypotenuse being 3 for us. Perfect. And what is cos theta? Let's figure this out. Adjacent square root 5. Okay. And 3. Perfect. Now there's one part. Now the other part is looking from the side k. Okay. So from k, how does it work out? Let's see from k. So sine k will be what? Sine k will be opposite side of square root 5 over hypotenuse is 3, and cos k is equal to adjacent side 2 over 3. Now it says verify that sine theta equals to cos k. So sine theta equals to cos k. You can see their values match, right? So yes, it is. Yes, so verify. You get the idea. So check mark. Explain if cos theta will be equal to sine k. Well, we see that they are related, correct? Then the thing is, how do we explain? So that's the communication portion, right? So the idea here is that the angle k is basically equal to 90 degrees minus theta. You understand? And when you look from angle K, what really happens, as you can see, that the sides interchange. So opposite and adjacent, they interchange, and therefore sine becomes cos and cos becomes sine, right? So what we get normally is as a rule, which is sine of 90 minus theta in degrees will be equals to cos theta. You get the idea. This is called cofunction identity. This is called cofunction identity. These are complementary angles, right? So that is what we mean by cofunction identity. You understand? So it is always true. Perfect. So with that in mind, let's move on. Take up the next part. So here, it's the same thing. Okay. Explain why the maximum value of sine theta is 1. Important question. Explain why the sine theta value is 1. Okay, let me go back to question number, example 5, which seemed to be 5. I'll just change this, okay. So we did this part. Let me just write 5 here. And in the same triangle, I'd like you to find tan value of theta. So let's find tan theta. Last time we did not, right? So look here. Tan theta will be equal to 2 over square root 5, correct? Now in this case, what you notice is that square root 5 comes in the denominator. Now that is not very good. So we need to rationalize. How do we rationalize? That is what I'm going to show you now. So square root 5 is there in the denominator. We'll multiply and divide by square root 5. The same thing. Then what happens? Then we get in the numerator 2 square root 5, right? And what is square root 5 times square root 5? You can say square root 25, right? Or 5, as you wish, right? So basically, you have to write your answer tan theta as equal to 2 square root 5 over 5. That is actually the perfect answer. Is that clear to you? So it is very important to rationalize, especially when you get a radical in the denominator. So surds in the denominator need to be rationalized. Perfect. Okay, that's good. So let's continue with example 6, which is a communication question. It says, explain why the maximum value of sine theta is 1. Can you tell me? So, simple logic. We have a triangle, correct? We're talking about a right triangle. So in a right triangle, we have, let's say this angle, theta. So this side is opposite side, and this side is hypotenuse. Now what is sine theta? Sine theta is the ratio of opposite over hypotenuse. And you know what? Can opposite side be greater than hypotenuse? No. So opposite side will be less than hypotenuse. Is that clear to you? But you know there is a special case where it could also be equal to. So what happens is, if you keep on increasing the angle theta, you see the triangle becomes kind of like this and this. Do you see that? So sine theta increases. Do you see that? Sine theta increases as theta increases. So imagine what happens when theta goes to 90 degrees. So when theta becomes 90 degrees, the opposite side is equal to hypotenuse. And that is where it becomes 1. You get the idea. So therefore, the maximum value is 1. You get the idea. Since sine is the ratio of opposite to hypotenuse in a right angle triangle, hypotenuse is the longest side. Therefore, opposite side will be never greater than hypotenuse. It could be, in a very special case, equal to hypotenuse when the angle theta is 90 degrees. Perfect. Straight vertical line. Steep. That sine theta value is 1. Perfect. Now here is question number 7, which says, find sine theta, cos theta, tan theta, rationalize denominator if required. So let's figure this out. And now, this is a triangle where we have x values, right? So we are not really given you a number like 3, 4, 5, okay? We are writing. Okay, so sine theta. So what is sine theta equals to? Now you know sine theta will be opposite over hypotenuse, correct? So it is x over x square root 5. Now you can cancel x and you can rewrite this as 1 over square root 5. You need to rationalize, right? So we'll do 1 over square root 5 times square root 5 over square root 5, which is square root 5 over 5. Makes sense? You see this part? That is how you have to write down your answer, and this process is called rationalization of denominator. It is required in this case, and therefore I did it. Now what about cos theta? Well, cos theta is adjacent side being 2x over x times square root 5, which is 2 over square root 5, since x and x cancel. So we'll again rationalize it. So it's for you to practice. Get ready for future, right? Perfect. About the tangent ratio, tan theta is what? Well, tan theta is opposite side of x, adjacent of 2x is half. You don't need rationalization here. Remember SOHCAHTOA, SOHCAHTOA, right? Opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Remember that. Perfect. We're almost coming to an end with some communication questions. Now, we're discussing about very important identity, which is quotient. Quotient means to divide. You need to prove that tan theta is sine theta over cos theta, right? So quotient of sine and cosine is tan. So what I'm trying to say is that quotient of sine and cosine is tan. Let me write tangent. Make sense? Okay, let's take up a triangle. Always a right angle triangle to prove these identities, right? So I'll make my right triangle, which is ABC for us now, right? We're talking about this angle theta. We can say sine A also, right? So what is sine theta for us? Sine theta is CB over AC, right? And what is cos theta for us? In this triangle, it is AB over AC. Perfect. And now, what is the ratio of sine theta over cos theta? Let's figure this out, right? No harm. So it is CB over AC divided by AB over AC, right? So AC cancel. We are left with CB over AB, correct? So CB over AB is what? Well, CB is the opposite side and AB is the adjacent. So it is tan, correct? Makes sense. Simple as that. So in any triangle, the quotient of sine and cosine is tangent, right? You can go back and see when we evaluated some numbers for the ratios, that is how tan is related. So check your results. Perfect. So remember that sine is opposite over hypotenuse, cos adjacent over hypotenuse, tan being opposite over adjacent. So the ratio of this is that, okay? Cleared? Example 9. Find an expression for sine theta, cos theta in the given triangle. Then, or otherwise, evaluate the value of sine square theta plus cos square theta. Now, this is also an identity. We'll find the value and then you'll know exactly what it is. Well, we are given a right triangle where two sides are A and B. We are not given the hypotenuse, but I can always write it down for you. You can calculate. This will be simply A square plus B square square root. Perfect. So what is sine theta? Well, clearly sine theta is equal to A over square root of A square plus B square. And cos theta is B over square root of A square plus B square. Is that clear to you? Now, if I want to do square of these and add them up, then what? Let's figure this out, right? Sine square theta plus cos square theta. Well, this is how we write sine square theta, right? So think like this. Sometimes you may say, let me write here, right? Sine theta whole square, right? But that is not the normal way. The normal way is sine square theta, written like this. Is that clear to you? Another way of writing. Now, sine square theta in our case will be what? A over square root of A square plus B square, correct? And we'll square this. Makes sense, right? And cos theta will be B over square root of A square plus B square. Perfect. And then we square it. So as soon as you square these things, what do you get? You get A square over, the square root becomes like A square plus B square, right? Plus we have B square over A square plus B square. So A square plus B square is common. So what do you get here, right? You get 1, right? Or you can go one more step, writing A square plus B square over A square plus B square. Is that clear to you? Correct. So you see that this is always equal to 1 and therefore it is an identity. So very important. It's called Pythagorean trigonometric identity. Okay. We're coming to an end with last two questions. Find the expression for sine theta and cos theta in the given triangle and then otherwise evaluate this. So this is for you to do. So reconfirm. Okay. So do it yourself. Last question for you. Now that's a difficult question. Say, if tan theta is 0.75 in the given triangle, find the values of sine theta plus cos theta. Oh my God. So we given A and B. How do we relate it? So can you pause the video, try to do it. Tan theta is 0.75. Now you can see tan theta is A over B, right? So the best way to do is what? Convert decimals to fractions, means 75 over 100. Makes sense, right? Simplify to the lowest terms, means dividing by 25, right? 3 over 4. Now, we are very close to our solution. SOHCAHTOA, right? Sine, cos, and tan. So, what is tan? Tan is the ratio of opposite over adjacent side. So, this ratio will be what? Well, clearly, this means from theta, the opposite side is 3 and adjacent is 4. Makes sense? And then you can calculate hypotenuse, which is 3 square plus 4 square square root. Pythagorean triple, right? You get 5. So do you see how we solve the triangle first? So that is how we can actually solve a triangle. You get the idea. So it's a very beautiful example. Now we can find what sine cosine is, right? So now we can say what is sine theta plus cos theta is. Sine theta is 3 over 5 and cos theta is 4 over 5, which is 5 is common, 3 plus 4, and which is 7 over 5, correct? So their sum, which is 7 over 5 in this particular case. You get the idea. That is how we do it. So I think we have completed all the examples, got a good idea. Now, you can go through these test practice questions. Perfect. Very similar to what we did, find the primary trigonometric ratios for the angle theta. And remember to rationalize, okay? That's kind of important. Question number 2. So in this case, explain why sine theta equals to cos k. So you have to explain the cofunction identity. I know you know it, but it's a communication question. You need to explain. Question number 3. Write the trigonometric ratios for the given triangle. So you have to find the third side before you start writing. Question number 4 is similar. And just to give you practice, right? So it's an isosceles right triangle, very special. So you will see check why this is so, right? It's a very good question. Verify that sine theta equals to cos theta in isosceles right triangle. Question number 5 is write primary trigonometric ratios. We're given x's will cancel, right? These are ratios. Perfect. Write primary trigonometric ratios. Another example, similar one. And then write primary trigonometric ratios in lowest terms. But remember to rationalize, correct? And you define. So we got some radical values, and that is why I've included them just for your practice, right? Some radical values here. Now with this, I think you come to realization of what this trigonometry is. In the next video, we'll actually find the angles, right? The last question, I made it simple, simpler than my example. So sine x is half, find the value of tan and cosine x. Perfect. So with that, we come to an end of our video, and I hope you learn. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. And if you want to learn from me, send an email on the address given. In the next video, we'll look into the inverse of these trigonometric ratios. That is, not just evaluating the sides, but to find the angles of triangles. Perfect. Thank you and all the best.